Hey guys, in this video we're going to be talking all about lesson 2 of our first unit, which is all about function notation. Alright, so let's move to the first slide of the presentation, where we're talking about how to describe the way in which a graph is changing. So the graph that you see here represents a stunt pilot doing a stunt that's called the dip of death. So we have 5 questions that we need to answer. First of which is, what are the independent and dependent variables? So if you remember from the last lesson, the independent variables are your inputs, and the dependent are your outputs. Independent is always x, output y or f of x. So the answer for number 1, your input is time in seconds, and your output is the altitude in feet. All right, number 2, what is the significance of the point 0, 3,500? So let's find that point. 0, 3,500 is, well, it's supposed to say 4,500, so I'm going to fix that on the slide. So let's change this to 4,500. This is the point that I want to focus on right there. That is called your y-intercept, which is also the starting point of your graph. So what this means is the stunt pilot started the maneuver at 4,500 feet. So the pilot started his maneuver, or the maneuver, at 4,500 feet. So anytime it's asking about the y-intercept, it's just talking about where something started. Number 3, where is the graph increasing or decreasing? All right, so let's start with increasing. Now remember from the last video, increasing means that as x is increasing, y is also increasing. So if we're looking at the graph, it appears that this segment here is where the graph is increasing, just right there. So we are going to write that as an inequality. So it starts at 4,500 and finishes right about where this point is here, which is at 5,000. So the smaller number is the 4,500. Or sorry, that's the y value. I keep forgetting we need to do x's, not y's. So at 4,500, that's times 0. So we're going to change this to 0. My apologies. And then the stopping point at 5,000 feet in the air happened at 20 seconds. Now remember, those are x values, so we need to put an x in the middle, and that was 20 seconds. All right, now the decreasing is basically the rest of the graph. So if you look, at this point is where he starts to dip. Just keeps dipping, and eventually it flattens out. All right, so I'm going to say that the decreasing portion of this graph is basically from that point all the way to about there, because here he's just kind of leveling out. So we're going to say decreasing starts around 20 seconds and finishes at about 40 seconds, give or take. All right, so that's number 3. 4 says, what is the relative maximum and what does it represent in the context of this problem? Same question for the relative minimum. So first we need to understand what a relative max and a relative min are. Well, we know that the word maximum means highest point and minimum means lowest point. So from this graph, we do have a highest point. It's this point, A, right here. So for number 4, I'm going to say that my max is at the point 25,000, which means after 20 seconds, the pilot reaches the max height of the maneuver at 5,000 feet. All right, now let's talk about relative min. From this graph, there really isn't a minimum point that is so obvious like the maximum is, because down here at some point it levels off. So we can just kind of talk about where that leveling off happens, which is right about where this curve is. So we're just going to call it right around there. Again, the word relative means approximate in this case. So we're not looking to be perfect. All right, so the relative minimum here is right around, let's say 41, 42, and the height is just under 500. Let's call it 400. So that means that after 41 seconds, the pilot reaches a relative min of 400 feet before leveling off. Because if you see here, it just kind of starts going the same height the whole way. That means the pilot is traveling at a constant height there. So that was number 4. Number 5 says, what are the domain and the range? All right, so remember, domain is talking about your x values, range, your y's. So here we go. Number 5, domain, and this is a continuous graph, so we are once again going to write it as an inequality like we did here. So for my domain, it's x in the middle. The farthest left the graph goes is right here. That's a point, so that's at 0 seconds. Now the farthest right the graph goes is right here. That's an arrow, which means it keeps going forever. Obviously, at some point, the pilot would land, but since there's an arrow there, we're gonna use infinity. All right, now the last one here is the range. So the lowest the graph goes is down here. Once again, that's the arrow. So he kind of levels off here though. So since we're giving a domain that works for what's going on here, we're gonna say levels off right around there, which is, I don't know, 100 feet. Less than or equal to y, less than or equal to, the highest he gets was this maximum point here, which was 5,000. So those are your domain and range. All right, let's move on to the next problem. Same idea. It says the graph to the right models the profit in thousands of dollars given the price of dollars that a comic book store charges for its comics. All right, so as you can see, this graph also has a curve here. So let's figure out what's going on. It says, what are the independent and dependent variables? So same as before, independent input, which is your x. So your independent is going to be the cost per issue. Your dependent is your f of x, or your y, that's the earnings. All right, number 2, where's the graph increasing? Where is it decreasing? All right, well, that's pretty simple. So if you think about where it's increasing, that's where the graph is increasing as x gets bigger. So that's this segment right there. Okay, so it starts at x is 0 and finishes right here at x is 4. So from 0 to $4, it is increasing. Decreasing, on the other hand, is this half of the graph. So that is from $4 to $8. So that's your increasing and decreasing. Number 3, what is the relative maximum and what does it represent in the context of the problem? So here's our relative max. It is at the point 480. And that means that at $4, or it basically what it means is $4 is the max cost that results in max earnings. And the reason we know this is because look on either side of this point. If the cost is anything less than 4, you have less earnings. Same thing goes for if it's more than 4. Okay, so $4 seems to be the right price point for the comics at this store. All right, number 4. What are the domain and the range? Okay, start with the domain. Again, that's your X values. The farthest left the graph goes is right here. That's an endpoint. That's at X is 0. And the farthest right is right here. Once again, that's an endpoint. It's at X is 8. The range, remember, is bottom to top. The lowest the graph goes is here, which is where Y is 0. And the highest the graph goes is here, which is 80. So what that means is the comic books range from $0 to $8, and the earnings range from nothing to $80,000. All right, next one. Mason works at a movie theater after school. The function f of x equals 9.25x represents the amount of money he makes before taxes for each hour that he works. Part A, what does x represent in this scenario? Well, x is our input, so x represents the number of hours that he works. My f of x, or my dependent variable, is the amount of money that Mason makes. So the way that I know this is that the amount of money that Mason earns depends on how many hours that he works. So that's why x is the number of hours, and f of x, or y, represents the amount of money Mason earns. All right, part B. Is this a function and how do you know? Short answer, yes. The amount of hours that Mason works results in only one amount of money. So yes, each input, which is number of hours, has only one output, which is earnings. All right, now here's where the function notation comes in that we haven't talked about. C says, evaluate and interpret each of the following. So we have f of 8. Notice that it is written similarly to this f of x here. So what they've done is they've taken and replaced the x with a number. So for part C, f of 8 means money Mason earns for 8 hours of work. So what we're going to do is we're going to take that 8 and we're going to plug it into the function that we were given. So here's where your handy dandy calculator will come in, unless you feel like doing it by hand. Up to you. So we have 9.25x. Now remember, a number right next to a letter means multiplication. So 9.25 times the 8 hours they gave us is $74. So f of 8 equals 74, which means 8 hours of work earns Mason $74. And the others are all similar. They're just a different value for our x. So part B is f of 14. So f of 14, instead of putting in, instead of multiplying by 8, I'm going to multiply by 14. So 9.25 times 14 is 129.50. So that means 14 hours of work earns Mason $129.50. All right, last one for this problem. We have f of 27.5. Same idea. So we have 9.25 times the number of hours, which is 27.5. That's 254.375. Now this is money, so we're gonna wanna round to two numbers after the decimal. So the number after the 7 is a 5, so we're gonna bump that 7 to an 8. So this is 254.38. So that means 27.5 hours of work earns Mason $254.38. And there are multiple different ways for you to write that same sentence. In fact, the way I wrote it is a little bit silly. You could say that if Mason works 27.5 hours, he will earn $254.38. It means the same thing. All right, same idea here for this next one. It says, Violet starts the semester with $150 in her lunch account and spends $3.75 on lunch each day. The function that you see there represents the amount of money in her account after a certain number of days. All right, part A wants to know, what does X represent in this scenario and what is f of X? So X represents, so we need to know what's the independent and what's the dependent. Well, we know that our variables are, let's see, amount of money in her account and number of days. Now, if you think about when you go to the lunchroom, when they take money off your card, the amount that's left on that card is dependent upon how many days you've been taking money off of it. So that means X represents number of days, Y represents money remaining. Okay? Now part B wants to know, why is the 3.75x negative? Well, it's pretty simple. She is spending the money. So Violet is spending the 3.75 each day, which is a negative change in money. So the amount in the account is going down. That's why it's negative. All right, part C, is this a function and how do you know? Well, for each day that she takes money off the card, there's only one amount of money that she could have remaining. So the answer is yes, it is a function. Each input, which is days, has one output, which is money remaining. Okay. And then part D is where we see our function notation. So for part D, we have f of 0. So if I take this and I plug 0 into the function, so I have negative 3.75 times 0 plus 150, I get 150. Now it's important to note that that 0 in there means no days have gone by. So essentially what they've given us here is the starting value. So Violet starts with $150 on the card. All right, next one is f of 33. So same thing, negative 3.75 times 33 plus 150 is 26.25, which means after 33 days, Violet has $26.25 remaining. Okay? And then the last one is f of 40. So we have negative 3.75 times 40 plus 150, and we get 0. So that's pretty simple. What that means is after 40 days, Violet has no money left. All right. Next one, we got a couple problems left. So we've done function notation from a scenario. Now let's do it from a graph. All right, so this one's all about Fernando and his pool. It says Fernando uses a garden hose to fill his empty pool. The graph to the right shows the amount of water in gallons, which is f of x, the pool contains after x minutes. All right, so number one is actually pretty easy because they kind of told us what they were already. So number one, the independent variable is number of minutes. And the dependent variable is amount of water, which is in gallons. You could also just say number of gallons. That works as well. All right, number two, finding function notation from a graph. So we have f of 5. So it's the same idea. Remember, the number inside the parentheses is your x value. So what I'm going to do is I'm going to go over to the graph and I'm going to find where the 5 is on my x-axis. So I noticed that they've labeled every 10 minutes, but there's a line in between, so it's really counting by 5s. So that means that 5 minutes is right here. What I'm going to do is I'm going to go up until I hit the graph, and then I'm going to figure out what amount of water is in the pool at that time. Well, I get 60. So f of 5 equals 60. So what that means is after 5 minutes, the pool has 60 gallons of water. All right, the next one we have is f of 20. So once again, find 20 minutes, which is right here. Go up until you hit the graph and figure out how many gallons that is. It's 240. So that means after 20 minutes, the pool has 240 gallons of water. And then the last one here is f of 25. So if I go back to my graph, here's 25. Go up until you hit the line, go over, that's 300. So that means f of 25 is equal to 300, which means after 25 minutes, the pool has 300 gallons of water. All right, one last problem. The graph to the right shows the number of people, f of x, at a gym X hours after the gym opens. All right, once again, it wants to know what the independent and dependent are, but they were really nice and told us what X and Y are, so that makes it easy. The independent, which is always X, is the number of hours, and the dependent is the number of people. Simple as that. All right, number two is where we have all of our function notation. So the first one is f of 0. Now remember, when they give you f of 0, they are giving you the starting value. So f of 0 is right here. It's my y-intercept. So I need to figure out what the scale of my y-axis is here. They're showing me every 40, but there are lines in between, which means the scale is 20. 20, 40, 60, 80, 100, etc. So that means f of 0 is 20. Now f of 0 is when the gym opens. So when the gym opens, there are 20 people there. So that might mean there are 20 employees. It might mean there's a line outside waiting to get in, and as soon as they open it, that's how many people are there. It could mean various different things. All right, f of 12 is right here. That's right on the x-axis. So that means f of 12 equals 0. So I'm going to assume that that's when the gym closes. So there are no people in the gym when it closes. Okay. Next one is f of 4, which is right here, up until you hit the graph, over, that's 40. So f of 4 equals 40, which means 4 hours after the gym opens, there are 40 people there. Okay. Last one is f of 6. All right, so let's go back to the graph. Here is 6. Go up until you hit. Now, it's not perfectly on there. That's okay. We're going to estimate. It's right about there-ish. So if I know I'm counting by 20s each time, let's say that's about 10. It's like halfway. So we're going to say that's 90. So equals 90, which means 6 hours after the gym opens, there are 40, oop, not 40, there are 90 people there. And that's it. That's basically how you do function notation for both scenarios. We did equations and we've done graphs as well.